Okay, we can also use the coordinate plane to solve inequalities with one variable. Now, with one variable, we did use the number line before, but if they ask you to do it in the coordinate plane, here's how you would do it. So let's solve and graph 3x plus 5 is less than 14. Now, you'll know if they want you to use a graph, if there's like a graph in the problem or they ask you to graph it. If it's just a number line or there's a number line in a problem, do it the number line way. So you got to first solve it for the variable. Okay, so solve it as an equal to. So subtract 5, divide by 3, you get x equals 3, and you graph the line x equals 3 with a dashed line because it's strictly less than. All right, then choose 0, 0 as a test point and test those values in the original inequality. Now, I know if you test the point 0, 0, the x is 0 and the y is 0, and you might think, well, there's no y to substitute 0 into, so how can I do it? Don't worry about it. Just put 0 in for the x value. Okay, if you put 0 in for the x value, you would get 3 times 0 plus 5 is less than 14, which is 5 is less than 14. And that works. So remember, x equals 3 is a vertical line going through 3 on the x-axis. I would graph that as a dashed line because it's strictly less than. I tested 0, 0. It worked, so I shade that side. Okay? It's pretty much that simple. All right, go ahead and try these ones. All right, so 3a, you got to have 4x. Oops. 4x minus 3 is greater than or equal to 17. But do the equal to. So add 3. You get 4x is equal to 20. Divide by 4. You get x equals 5. So you would go over 5, put a point, and it's or equal to, so you put a vertical line that's solid, and then you test 0, 0. So you have 4 times 0 minus 3 is greater than or equal to 17, which would be negative 3 is greater than or equal to 17. That's not true, so you don't shade this side with the origin, you shade the other side like that. Okay? 3b, you have negative 2x plus 6 is equal to 12, so we got to do the equal to part. Subtract 6, negative 2x equals 6, divide both sides by negative 2. You get x equals negative 3. So you go over to negative 3, put a dashed line at negative 3. Then you test the origin in the original inequality. So negative 2 times 0 plus 6 is greater than 12, which would simplify to 6 is greater than 12. That's false. So here's the origin. There's the line. I shade the other side. All righty. All right, one more example, guys. An inequality can be viewed as a constraint in a problem situation. Each solution of the inequality represents a combination that meets the constraint. In real-world problems, the domain and range are often restricted to non-negative or whole numbers. So a yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35 and each class ring costs $140. How many yearbooks and class rings must the junior class buy to get the picnic? So you need to know the cost of each item and the minimum amount the class needs to spend. So if X represents the number of yearbooks and Y represents the number of class rings, we can write an inequality. So $35 times each yearbook plus $140 times each ring has to be at least $28,000. So that would be 3 times X plus 140 times Y is greater than or equal to $28,000. So then I could solve that equation for Y. So subtract 35, or that inequality for Y. Subtract 35x from both sides. Divide everything by 140. And if you simplify this fraction, it comes out to negative 1/4. Okay, so as y is greater than or equal to negative 1/4 x plus 200. Because the yearbook company cannot sell a negative number of items, the domain and range must be non-negative numbers. So you graph the boundary with a solid line because it's or equal to inequality. If we test 0, 0, the result is 0 is greater than 28,000, which is false. So we shade the closed half plane that does not include 0, 0. So here's our line, negative 20.25x plus 200. So right there. I tested the origin. It didn't work, so I shaded everything else on the other side. Since x represents yearbooks and y represents class rings, it doesn't make sense to graph anything over here, here, or here, because that would imply negative yearbooks or negative class rings or negative of each. Okay? So I shade that side. Now, if I pick any point in here, for example, if I pick, let's just do 500, 100. That means 500 yearbooks and 100 class rings were sold. If I did 500 yearbooks, I would do 35 times 500 plus 140 times 100, and that would be greater than $28,000. If I picked any number up here and substituted those coordinates into the inequality, it would work, and the coordinates of that inequality, or that point rather, would represent the number of yearbooks and number of rings. Now, I could also pick a number right on the line because that's the boundary and the boundary is included. So any point on the line is also going to work. Like if I pick 200, 0, or 0, 200, that would also work. Alrighty. So we did all this. All right, Neil wants to run a marathon at a pace of at least 6 miles per hour. Write and graph an inequality for the miles y that he will run in X hours. Go ahead and pause the video. All right. So since it's an at least, that implies an inequality that's going to be greater than or equal to. So the number of miles he runs, y, is at least greater than or equal to 6 miles per hour times the number of hours he runs. So y equals 6x. If I graph that, x represents miles, or hours rather, and y represents miles. So if he goes 0, it won't go anywhere. If he goes 1 hour, it's 6 miles. 2 hours would be 7, 8, 9, 10, 11, 12. Would be 12 hours. And it's at least, so it's or equal to, so it goes up here. And he can't run negative miles or negative hours and be realistic. Now, the origin is not a good idea to test because it doesn't tell you anything because it's right on the boundary, so you don't know which side to shade. So I'd pick the point 1, 1. Does it work? 1 is greater than or equal to 6 times 1. That would imply that 1 is greater than or equal to 6, which it's not. So you don't shade the side. Now the point 1, 1 would be right about there. You don't shade that side. You shade the other side, which would be right up here. And notice I just shaded the little v in here because if I shade it over in here, that would imply some negative hours. So you just shade everything in the first coordinate there. Alrighty? All right, guys, that's it for this section. As always, continue to reach out to me if you have any questions. Go on to your next assignment and take care.